Hi everyone. In this video, I am going to explain about the behavioral model of a VHDL code. So in VHDL, as I said in the previous video, there are three different styles of programming available. First one is behavioral model, second is data flow, and third one is structural. Behavioral model is most commonly used and it is very easy to understand just by seeing the program, because see, VHDL code is not a new one. Already whatever we have studied in the C programming, the same C programming, the same methods we will use here also in the VHDL, but its own data types are different compared to the C programming. Okay, I will explain in detail. So behavioral model, in behavioral model what we will write, on what basis we write the program, I told you. So in behavioral model, we write completely based on the truth table. So we write programming, we write programming, we write VHDL program based on truth table, based on truth table. So whatever the truth table says, if else conditions will be used, and then we write the code. For example, see, programming I will explain with all examples only. Okay, without examples, simple syntax you cannot understand. If you just simple syntax you can understand once if you understand the programming. Okay, that's why I'm just explaining the examples. So consider a full adder, consider a full adder. So this is the full adder. Okay, by this time you must know what is a full adder. Full adder is a logic circuit which is used to add three bits of information. That means A, B, and this is C. Here C is nothing but carry input, and A, B. These are the three inputs available for the full adder, and two outputs are there. Two outputs are there. So this is sum and this is carry, which is C out. Carry is nothing but C out. So three inputs are there, two outputs are there. Now first we need to write an entity where it specifies three inputs and two outputs, and all are one bit memory, one bit location only. Okay, so entity name is nothing but something like full adder is entity full adder is port of A comma B comma Cn. Three inputs are there, and all these three inputs are input ports. So A comma B comma Cn input. You can use here, it is standard logic, std underscore logic. Vector is not needed because all these are single bits. A, B, C in, and outputs are sum comma carry C out. Here it is out direction and std underscore logic. So end full adder. So with this, entity part is completed. So in entity, I told you we specify only what are the inputs and what are the outputs, in which direction that means whether it is input port or output port, we specify that only. We don't have any other chance to specify that. Next one is architecture. Architecture architecture name, let us consider a behavioral and of. So for which entity we are writing full adder is, so architecture name here we are just keeping it as behavioral of full adder is begin. If any signal statements are needed, we can write here, otherwise begin. Now see here, for full adder there are three inputs like A, B, C, N, and two outputs sum and carry. So three inputs are 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, and triple 1. So sum is nothing but addition of all A plus B plus C, 0, and carry is 0. Here it is sum is 1, carry is 0, sum is 1, carry is 0, and here it is sum is 0, carry is 1, because 1 plus 1, carry 1, sum 0, and here it is 1 0 0 1, again it is 0 1 1 1. Okay, so sum is 1 here, 0001 0 0 double 1 0 1 double 0 1. So this is what your truth table of the full adder. So truth table of the full adder says what is the sum and what is the carry. According to this truth table, we have to write if so before that the behavioral model uses a statement called process. All the items whatever we are writing for the relation between input and output, we should specify them in process statement. So process of what are the inputs of for our logic circuit, that we need to specify a comma b comma cn, a comma b comma cn. Here process is a statement or a condition or a block where we specify all the relations between input and output in that process. Begin, so this begin belongs to architecture and this begin belongs to process. So process begin. Now if what is the first condition, a is equal to 0, b is equal to 0, c is equal to 0, and operation between all these, a equal to 0 and b is equal to 0 and c is equal to 0, then sum is equal to 0, carry equal to 0. Else if again a equal to 0, b equal to 0 and c is equal to 1, then s equal to 1 and carry equal to 0. Like that we need to write 8 different statements. So if a is equal to 0, 0 should be specified in a inverted quotations. 0 should be shown in quotations, and b also equal to 0 and c in also equal to 0. Then you can keep all these in a bracket. Then sum is equal to 0, and the next line we can write it as c out is equal to 0. And similarly second line, if a is equal to 0 and b is equal to 0 and c in is equal to 1, then sum is equal to 1, carry is equal to 0. So like this we will write all 8 combinations, 8 combination equations, all 8 combinations equations. Okay, so I will write the last one. If, yeah, next if will be else if, if then if this condition is correct, it will give you s equal to 0, carry equal to 0. If this condition is wrong, then else if e is not there. Again last one, else if last a is equal to 1, b is equal to 1 and c is equal to 1, then s is equal to 1, carry out is equal to 1. Now what we need to end if whichever is the latest block open, that we need to end. So end if, end process, and go back to architecture, end architecture. Okay, architecture name, end architecture name. Okay, what is architecture name for us? It is behavioral. I will let behavioral only. So end behavioral. Okay, so what we have done here, we have taken first the truth table, and once we are familiar with the truth table, then if else conditions, using if else condition, we will write all the statements, and so that what is the output also we are writing. Okay, all these if else conditions should be written in process statement. Process is a statement or a block where it consists of all these if else or any conditional statements for our behavioral modeling, for the behavioral modeling. Okay, this is what the behavioral model. Okay, thank you.